The next section is section 1.2, formulas and percents. So you now know how to solve linear equations, but I really want us to talk about how you would solve an equation like example 2 right here. So how about you actually try this on your own first before watching the rest of this video. Put it on pause, solve example 1 going through the steps A, B, C, and D, and then do exactly the same thing to solve number 2 here that is exactly the same form as number 1, except the A is like 7, the K is 8, the C is the number 3, and the T on the other side is the number 12. So you'd have to do exactly the same thing except with variables. So give it a try before you actually watch the video. So now we'll actually go through these piece by piece. Clear the first equation of fractions by multiplying by 3. That C is actually in the wrong place. This belongs over there. So we have to multiply both sides of this by what to clear the fraction? By 3. So on the left side, 7x plus 8 over 3. Hopefully you recognize by now that that would give us 7x plus 8. And on the right, it would give you 12 times 3, which is 36. So I want you to do 1a and then 2a. So we're going to go back and forth. I'll use a different color to do 2a. If ax plus k over c is equal to t, we're trying to solve this for x, by the way, in both of these. We're going to multiply everything by c. If we multiply the left side by c and the right side by c, on the left the c's will cancel. You'll get that ax plus k, because the c on top will cancel with this c. There was a t over here that you can no longer see. T times c would give you t times c. In part B, on the left, subtract 8 from both sides of the equation. So 7x plus 8, I'll subtract 8 up here, and then I'll put the conclusion down here. That would give you 7x is equal to 28. And then back here, subtract k on both sides. Ax, I'll just do that up here too, I forgot. Minus k, minus k. Now this is where things get a little bit weird. On the left, everything is as it always was, right? You've got this plus k and this negative k, which means, as you would expect, they will make 0. That gives you ax on the left. But on the right, these aren't like terms. But it doesn't really matter. You can write it as t times c minus k. There are no like terms really to combine in either example. I guess I already did that here, really, by canceling out the k's. Then you want to divide each side by the coefficient on x. So you have 7x is equal to 28 on the left. To get x alone, we need to divide by 7. That will give you x is equal to 4. Let's carry down the equation here. A times x is equal to t times c minus k. You're trying to get the x alone. And read what part D says. Part D says divide each side by the coefficient on x. What is the coefficient on x? It's this a. Even though you don't know what its value is, it doesn't matter. If you divide both sides by a, these a's will cancel and make a 1. Doesn't matter if you don't know what the number is. And this will give you that x is equal to t times c minus k, all divided by a. So now that gives you an idea of how we'll be doing the rest of this process. So again, more examples for you to try on your own. I want you to solve the first 3 examples on your own for the specified variable. So in example 1, you want to get the letter b, the capital B, alone on the right-hand side. In example 2, you want to get the y alone on probably the left-hand side. And in example 3, you actually have to solve a word problem. If it takes Dorothy half an hour to drive 21 miles to work each day, what is her average rate? And it's okay if you don't remember how to do any of these. It's just that I want you to realize that maybe you don't remember how to do them. So if you do want to try them, feel free to try them now. I'll do those actually in the lecture because they'll show up again, I promise. So just try them now on your own, pause the lecture, and come back to the definition of a formula down at the bottom. So, defining a formula. A formula is an equation in which variables are used to describe a relationship. And it's a relationship that is always true. So, for example, there is a relationship that relates any Fahrenheit temperature to any Celsius temperature. There is a formula that relates area of a rectangle to the base of the rectangle and the height of the rectangle. The formula is always true. The numbers can vary, but the relationship between all the letters is always the same. So now we'll go over some formulas that you need to have memorized. The perimeter of a square. Perimeter always measures the distance around an object. So what do you know about squares? You know two things. That they have 4 right angles. Oops. That's not really the important thing in this case. But there are 4 right angles, but the more important thing about a square is that all 4 sides have the same length. So the way you measure the distance around a square is you add up all 4 of its sides, which is s plus s plus s plus s, which is 4s. That is the perimeter of a square. How about the perimeter of a rectangle? Very similar to the perimeter of a square. The difference, though, in a rectangle is that the 4 sides are not all the same. This is the width, this is the length. This is the width, this is the length. So perimeter of a rectangle, I want to make sure it doesn't look like a square. You add all the sides together, L plus W, so this L plus this W plus this L plus this W. But then you can actually combine like terms, and you get 2L plus 2W is the perimeter of a rectangle. Area of a square. And again, you probably remember some of these. The area of a square is side times side, or side squared. Area of a rectangle, I again suspect you remember this. It's length times width. Volume of a rectangular box. So I'm just drawing a little box for you. It's not going to be very good. I'm not a very good drawer. You get the idea. The dimensions are the length, the width, and the height. Volume is length times width times height, because you're basically taking this rectangle, whose area is length times width, and then filling the box this high up. Oops. The distance formula. I guess in that case I'm talking about the distance between 2 points. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Actually, I think that's not what I mean there. So keeping that in mind, that's actually not the distance formula I really meant. I really mean the distance equals rate times time, because that relates to the previous example. So looking at how to solve for a specific variable. This is what the questions in the warm-up were asking for. It's an important skill to be able to manipulate equations and solve for any specific variable. The first thing you want to do is clear any fractions, just like in solving linear equations. If it has fractions, multiply each side by the least common denominator to get rid of the fractions. Isolate all terms that contain the specified variable. So if you have 2 t's in your equation, move both t's to the same side and everything else to the other side. From there, you'll be able to isolate the specific variable by maybe doing some factoring. You'll have to do some algebraic manipulation and tricks to get it alone, but once the variable of the same type is on the same side, you'll be able to get that variable alone. So now back to the examples that we didn't actually get to do together. v equals 1/3 times base times height. We want to solve this for b. So again, you want to get the b alone. Let's first multiply both sides by 3, giving 3v on the left, and on the right, the 3 and the 1/3 will cancel, and you'll get b times h. Divide both sides by the h, and voila, you have b alone. 3v over h equals b. It doesn't matter which side the b is on, it's still true. 2x plus 7y is equal to 5. We want to get the y by itself. So then we can subtract 2x on both sides, which I guess I should write out, minus 2x, minus 2x. Again, these cancel here. On the right-hand side, you can make it 5 minus 2x or negative 2x plus 5. They are not like terms. Then the easiest thing to do here is to divide every single term by 7. So y equals negative 2x over 7 plus 5 over 7. A couple more examples. But I think we need to pause here.